Okay. Well, then this leads us, we're going to go below the glare now. Actually, we'll go above it. This leads us to a very interesting idea. And Afra kind of mentioned it already. And that is, you can notice here, the set of one element had a power set of size 2. The set of two elements has a power set of size 4. Three elements, power set of size 8. You might see a pattern. This is 2 to the 1. This is 2 squared. This is 2 cubed. It seems to be powers of 2. And the question is, why the hell do powers of 2 show up in power sets? Oh, wait, no, that's what I call power sets. Interesting. But the point is, like, why 2? Let's think about it. So, I'll just say the fact first, then we'll prove it. So the math fact, let A be a set within elements, then the power set of A will have 2 to the n elements. That's the math fact. And it works here, here, and here, as you can see. But why? So I'll say proof-ish, because it's not like a real proof, it's a proof-ish. Proof-ish. Consider the power set of 1, 2, 3. Because remember, the power set of anything with 3 elements is going to be the same, right? It's going to be analogous, so might as well consider like the easiest one we can think of, and that's 1, 2, 3. They said before, we'll have the empty set, we'll have the set with just 1 in it, the set with just 2, the set with just 3, the set with 1, 2, the set with 1, 3, the set with 2, 3, and the set with 1, 2, and 3, all these. All right. Let's notice what's going on with each of these things. In the empty set, remember, a set, right, just kind of, the definition of a set, we said everything is either in or out. And a subset, right, subsets of 1, 2, 3 are built from 1, 2, and 3. So a subset of 1, 2, and 3 is just a particular set where for 1, 2, and 3, we have to decide, is 1 in or is 1 out? Is 2 in or is 2 out? Is 3 in or is 3 out? So in the empty set, we have that 1 is out, 2 is out, and 3 is out. Right? They're just, none of them are in this set. For 1, the set is 1, we have 1 in, 2 out, 3 out. For 2, we have 1 out, 2 in, 3 out. For 3, we have 1 out, 2 out, 3 in. For 1, 2, we have 1 in, 2 in, 3 out. 1 in, 2 out, 3 in. 1 out, 2 in, 3 in. 1 in, 2 in, 3 in. Every subset of 1, 2, 3 really just comes down to making a decision about 1, 2, and 3. Is 1 going to be in or out? Is 2 going to be in or out? Is 3 going to be in or out? And notice, for any decision we make, 1 in or out, 2 in or out, 3 in or out, it's going to be a subset. Like randomly, if I just choose here, oh, okay, this is what we're going to do. Patrick first, then Herman, then Afra, right? Patrick, you say in or out. Herman, you say in or out. And Afra, you say in or out. You pick one. Okay, ready? So Patrick, is one going to be in or out?
In.
Herman, is two going to be in or out?
Out.
Afra, is three going to be in or out?
Out.
So we have one in, two out, three out. That's this set right here. Any combination you guys could have said of one being in or out, two being in or out, three being in or out, is going to be some subset. It's clearly going to be a subset of 1, 2, and 3. And every subset of 1, 2, 3 is going to be some combination of this. So the thing to notice is that the number of subsets is just the number of combinations of decisions for here's where you gotta go below the clear. The number of combinations of decisions for 1 in/out, 2 in/out, and 3 in/out. So how many ways can we combine these decisions to form elements? Which equals, notice, 1 being in or out, this gives us 2 options. 2 in or out, this gives us 2 options. 3 in or out, we have 2 options, right? Either in or out. So the number of combinations of options we have, decisions we have to make these subsets are, we have 2 here, 2 here, and 2 here. And so if you know anything about combinatorics, it's going to be 2 times 2 times 2, which equals 8 is the number of options. It's the same idea of if you flip a coin, if you flip 3 coins, right? Because they can either be heads or tails, heads, tails, heads, tails, same as in, out, in, out, in, out. If you flip 3 coins, what are the possibilities for what's showing? Like heads, heads, tails, 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 heads. What are the possibilities? Exactly the same thing. What are the possibilities for in, out, in, out, in, out? It's going to be 2 times 2 times 2 equals 8. I'll say that equals 2 cubed. G equals 8. Any questions?
Is it like probability, like finding the number of outcomes?
Yeah, it's exactly like that, Afra. Yeah, so probability, the probability of an event happening is the number of ways it can happen divided by the number of ways anything could happen. And so both of those, the top and the bottom of that, the number of ways it can happen and the number of ways anything could happen, are both, they're called a field of math called combinatorics. It's all about counting. It's about how many possibilities are there. And same thing here. The question is how many possibilities of in-out decisions can I make here? And the answer is going to be 2 cubed. It's going to be 8. So that's how the power of 2 comes in. The power of 2 comes in because, well, we have 2 decisions to make for every element in our set, either in or out. And then you raise to the power n because we have that many decisions to make. You have 3 binary decisions to make. I like this. I think this is cool. I think it was one of those things where it's like, it's not obvious at all why it works at first, but then once you explain it, it becomes really clear. So the point being, though, if we had just any number of elements here, like if P was the set, you can see that, if P was the set up to N, then if you think about it, we'd have n binary decisions to make. We'd have psi number of elements and the power set from 1, 2, 3, all the way out to n is number of ways to combine in/out decisions. Because for every element here, we've decided, is it going to be in the power set or out of the power set? And for every decision we make, that creates another set, like a particular subset. That's how you create subsets, by deciding if one's going to be in or out, two's going to be in or out, three's going to be in or out. So the number of subsets you can make is the number of decisions you can make. So it's a way to combine in and out decisions, which equals, so we have in binary decisions here. So we have 2 times 2 times 2 times 2 in times, which just equals 2 to the n. Good? I think that's fascinating personally.